Hi everyone, I'm glad to have this chance to introduce my research on wildfire monitoring by fusing radar and optical remote sensing imaging time series. In the past decades, wildfires are becoming larger, more frequent, and long duration across the globe, and tend to be more destructive both in life loss and economic costs, which makes wildfire plays an increasingly important role in reshaping Earth's surface and regional or even global climate. Compared to traditional field work for mapping burn areas, satellite-based observation systems can monitor wildfire progressions and assess environmental impacts over vast areas by providing timely and accurate information on Earth's surface, from local to global scale. Wildfire mainly cause both a reduction in leaf area index and moisture, and the chlorophyll reduction often result a strong decrease in the near-infrared reflectance after burning, whereas a reduction in moisture would lead to a significant increase in the short-infrared reflectance. The non-changing rate, the sharp decrease in near-infrared, and moderate increase in short-infrared motivated researchers to design many spectral indices for burn area mapping and burn severity estimation. At wavelengths ranging from 1 mm to 1 meter, sensors measure objects in two dimensions, backscatter intensity and phase. Backscatter intensity measures the total energy received by the sensor, reflecting the target scatter's properties, while phase related to distance between sensor and target. For wildfire applications, at T1, volume scattering would dominate for healthy tree. After burning, the scattering mode would be dominated by the combination of double bonds and surface scattering. If the tree was totally burned, the surface scattering will dominate, which makes it possible to identify burn areas with SAR by detecting temporal backscatter changes. This slide shows the comparison between temporal patterns of SAR and optical time series at a specific region. This figure shows the framework of training a unit for near real-time wildfire monitoring by the combined use of SAR and optical time series data. This figure illustrates two learning schemes for continuous wildfire progression mapping: continuous joint training and learning without forgetting. In this figure, visually compare the results from the continuous joint training and learning without forgetting. We can observe that learning without forgetting has the capability to reach the CGT. Here we overlay the SAR-based results on top of optical false color imaging. We can observe that there is a high agreement between SAR-based result and the optical visualization. Here, we compared SAR-based wildfire progression map with two lower resolution products, MODIS and VS daily progression maps, and we can see our result has much more details. We also developed a wildfire monitor web application to track wildfire progression based on multi-source satellite data in a near real-time manner.